Hi class, Mr. Cardinal here with section 2 from chapter 12, Equal Ratios and Proportions. Just a reminder, the definition of a ratio from yesterday's lesson is a relationship where for every x units of one quantity, there are y units of another quantity. Remember, there are three different ways of writing ratios. And again, ratios are used to compare between two quantities. So x to y, say number of boys versus number of girls in a class. A second way of writing it would be x with a semicolon to y, again meaning the same as the one above. And the third way of writing it would be as a fraction, x over y. Today, since you know how to find and write ratios, we are going to explore or learn about equal ratios and proportions. So you will find equal ratios and determine if two ratios form a proportion. Now, the definition of a proportion is when two ratios are equal. So again, proportion means when two ratios are equal to one another. Equal ratios, like equivalent fractions, can be generated by multiplying or dividing both terms by the same non-zero number. So let's take a look at the examples for our reteaching. Once again, you can find equal ratios just like you find equivalent fractions. Find ratios equal to 30/40ths. So we multiply both terms by the same number. We could take 30 and multiply it by 2 to get 60. If we take 30 and multiply it by 2, or since we are multiplying 30 by 2, we are going to multiply 40 by 2. So our fraction is 60/80ths. We can also divide, if we are allowed. In this case we are. We can divide both terms by the same number. To find the simplest form ratio, divide by the greatest common factor of the two numbers. So in this case, the greatest common factor between 30 and 40 is 10. So 30 divided by 10 equals 3. 40 divided by 10 equals 4. So 3/4 is also an equal ratio to 30/40ths. Two equal ratios form a proportion, as I mentioned earlier. The units must be the same in both ratios. So if we do the ratios, 24 feet is to 16 seconds and 36 feet is to 24 seconds, do they form a proportion? So first of all, let's check the units. Both ratios compare feet to seconds, so the units are the same. Okay, so if one was inches to miles, it wouldn't work. It has to be the same units for both. So since we have feet and seconds for both, we can find a proportion. Then write each ratio in simplest form. So 24 feet per 16 seconds equals 3 feet per 2 seconds, because 8 goes into both 24 and 16. 8 goes into 24 3 times and 16 2 times. So that's how we are able to get 3 feet over 2 seconds. 36 feet for 24 seconds, again, 3 feet per 2 seconds, because 12 goes into both 36 and 24. Compare the simplest form ratios. They are the same, so the ratios form a proportion. So ultimately, if you find the simplest form of your fraction or the simplest form of your ratio and compare it to the simplest form of the second ratio, if they are the same, then the two beginning ratios form a proportion. They are equal to one another. Let's take a look at several of the problems down here below. Write three ratios that are equal to the ratio given. Second here. So write three ratios that are equal to the ratio given. The first one is 3/5. And again, when you see a ratio written as a fraction, think of it as trying to find an equivalent fraction. And in order to find an equivalent fraction, we multiply the numerator and denominator by the same value other than 0. So we can take the 3, we can multiply 3 and 5 both by 2. If I multiply the 3 by 2, I get 6, and the 5 by 2 equals 10. Do the same thing, we can take 3, multiply it by 3, we have 9 and 15. And again, it does not matter what we multiply it by, as long as we multiply the same number to 3 and 5, the numerator and denominator, we will have an equal ratio or equivalent fraction. So if I even take it times 10, I have 30/50ths. It is a ratio that is equal to 3/5. The second one, I wanted you to notice the difference between the second value versus the first. Here we have 4/8. In this case, we can actually simplify this fraction or simplify the ratio. 4 goes into both the numerator and denominator, so the value or simplest form would be 1/2. And again, 1/2, we can take 1/2 and do 2/4. We can do, we can also multiply the 4 and the 8 both by 2, so we have 8/16. But in the end, all three of these ratios are equal or proportionate. 6/18, again, if we do the simplest form, we have 1/3. If we multiply both 6 and 18 by 2, we have 12/36. We can also take 1/3 and multiply both 1 and the 3 by a value to get an equal ratio. So if we take 2 and multiply 2 times 1, we have 2. 2 times 3 is 6, so 2/6 is also an equal ratio to 6/18. Keep in mind, when it is written, when a ratio is written with a colon, is the same as, it's the same thing as 8/10. Don't let the colon fool you. So you can still think of equivalent fractions when trying to find equal ratios when given a colon. And also the same when you see the word 2. Those are the 3 different ways of writing a ratio. You can think of them as fractions for all of them if it's easier for you to find an equivalent fraction. Now, I hope that this helps you understand a little bit more about equal ratios and proportions. Please come to class prepared with your answers to the questions on the Google Forms also attached to this assignment. And don't forget to bring any questions or comments to class with you. Thank you. See you tomorrow.